Okay, in this tutorial, we're gonna learn about the electrolysis. So it is the process in which electrical energy is converted into chemical energy. So whenever electrical energy is converted into chemical energy, it is known as electrolysis. It is a non-spontaneous redox reaction that takes place in electrolysis with the help of electrical energy, that is battery. So a battery, with the help of battery, electrical energy is converting into chemical energy. So the container where electrolysis is taken is known as electrolytic cell. So let's consider this electrolytic cell. In that, two electrodes are dipped into a solution and they are connected to each other with a battery, and there is a positive terminal of battery and also a negative terminal of battery. So negative terminal of battery is known as cathode, and at the cathode there is a reduction reaction takes place. So in the case of electrolytic cell, at cathode, reduction reaction is taking place, and at the anode, the positive terminal, the oxidation reaction does takes place. So on the cathode, a reduction reaction does takes place, and the anode, oxidation reaction does takes place. And anode is a positive terminal and cathode is a negative terminal, and the solution in which the electrolysis is taking place is known as electrolyte. So electrolyte is the solution in which the electrolysis is taking place and which is in the electrolytic cell. So that's how the electrolysis is happening over the solution. So electrode may be inert. Here electrode may be inert. Or reactive. We will be observing some example in which the electrode is inert, like platinum electrode in case of hydrogen, and in some other case we may see also the examples where the electrode is reactive, like here electrode is reactive, and in some case electrode may be inert also. Okay, so let's consider what is electrode potential. So whenever we have let's talk about an example in which zinc is dipped into its own solution. Whenever an electrode is dipped into its own solution, so let's consider this example in which the zinc and it is dipped into the solution where it is like a ZnSO4. So we know here zinc has a positive charge. Okay, zinc has positive charge and the electrodes are shifting from zinc to here. So here zinc has the zinc will be losing its electron to its solution. So as the zinc is losing its electron to its solution, so there is a polarity generated, and whenever there is a polarity generated, there is always a potential. As we see, whenever there is a polarity generated, that is known as potential, and in case of electrode, it is known as electrode potential. So whenever a metal is dipped in the own solution, there is a generation of polarity due to the charge difference. Okay, due to that charge difference, okay, here it is a negative charge and here it is positive charge. So that's how it is known as electrode potential. So when a rod is dipped into its own solution, polarity is developed, and due to this potential is developed and it is measured as a standard condition, and it is known as standard electrode potential. So whenever that zinc is dipped and then metal is dipped into its own solution, then in standard condition it is known as standard electrode potential. And standard electrode potential, if we talk about standard electrode potential, SEP, if we talk about, it is a intensive property. It is a intensive property. Intensive property means it is a mass independent. Whenever we have a zinc rod like 1 meter or we have like 1 centimeter, E naught will be the value of E naught, means it is a mass independent quantity.